should probably say that if you download the handout, you probably don't have to attend the presentation because basically we're talking about command strings here, so there's not a lot of value add in the discussion. You know, it's more questions and making sure I address what your interests are. How many people here are currently programming with ffmpeg? Okay, how many people are familiar with batch operation in Windows? Okay. Not part of the presentation. It's kind of interesting. The I guess it was in 2014, 2015, I started a book called Encoding by the Numbers, where I wanted to run a series of tests and then measure the results of those tests and then base recommendations on things like keyframe interval, B-frame interval, reference frames, based upon the numbers I got back from the metrics. So that way everything I recommended was backed up by objective quality metrics. And I started off using a program called Sorensen Squeeze, which worked fine, but you know, I was running dozens of encodes and working through a UI just didn't really cut it. So I ended up learning ffmpeg because I needed to accelerate how I encoded the files for that book. And then as part of the book, I said, well, since I'm learning it, I might as well share what I'm learning in the book. And then I wrote a separate, then I took that and put it in a separate book, and now I've got a training course on it. And along the way, I was really fortunate to work with a group from Realize, which is a consultancy. A couple of them spoke here. So they added a nice real-world element to what I was learning on the academic side, and also introduced me to Bento 4, which is the tool they actually use in a lot of their consultant work when they're creating systems for their customers. What I tried to do here was come up with a bunch of command strings that you could actually take back and use and encode, package, encrypt using pretty simple commands that are easily explainable and two free tools. So we're going to start out kind of on the Windows platform, then we're going to go to Ubuntu because I think that the automatic operation of batch programming just seems simpler on Ubuntu than it is in Windows. I'm sure you can do some of the stuff I'm doing in Windows, but the availability of cloud machines, running Ubuntu, and just some in my office kind of led me to learn it was easier to do it that way than to try it on Windows. So we'll start out with the shameless plug. I'll show you some of the products and books that I have. Then we'll cover the ffmpeg side, then the Bento 4 side, and then we'll talk about automating it all, pulling it all together in Ubuntu. And again, we're going to see a bunch of command strings for everything that we talk about. So really, you know, download the slides, and you've got pretty much everything that we'll be covering. So here's the two. Again, I wrote the book, Encoding by the Numbers. That has separate sections on ffmpeg in each chapter. I took those out and put it in a separate book, now in a second edition, 2018, which includes the stuff about Bento 4. And I've created, for people who like to learn by watching, there's a training course you can find, you know, at the URLs here. So some deals. You know, what I tried to do in the book was basically some of what you're seeing here, but it goes into a lot more detail. What's different about the book is that, you know, I don't just tell you how to insert keyframes into a file. I show you which keyframe intervals are best and why. So a lot of the mathematical metric information that I included in the Encoding by the Numbers book is in this book. And there's also a chapter on, you know, just introducing people to video if you're not familiar with video as it relates to the programming side. And then as an introduction, I should say that ffmpeg has dozens of ways to do almost any operation. So, you know, I'm going to show you the one that I've, you know, A, I was able to figure out, B, I was able to make it work, and C, seemed to accomplish its function pretty regularly. And then in a lot of these examples, I'm showing the minimum necessary controls. You know, you can see command strings that are, you know, 10 or 11 lines long. I tend to like the simplistic approach. You know, identify the file, I choose a preset, and then I encode. Because I find optimizations beyond that are a measure of diminishing returns. So I don't, you know, I try to keep my command strips pretty simple. I should say that the location of the configuration options in the command string typically doesn't matter. So the order of the switches doesn't matter. If you don't choose a configuration option, ffmpeg uses the default, and we'll cover a lot of that. Some things you don't need to specify, some things you do need to specify. And anytime you configure in the command line, you're going to override the default. So for people who came in late, you can download the handout at this bit.ly URL. I think this is the last page that has it, so. OK, so the most basic command in ffmpeg is the one you're seeing up here. Basically, what we're doing is we're calling the program, we're identifying the input file, we're identifying the video codec, and we're identifying the output file. I guess I should also say that the book includes the ability to download all the batch files that are covered in the book. So they're working Windows batch files for every operation. Pretty easy to convert them to Ubuntu, but I only did Windows. So this is the most basic command structure here. And basically what this does is it encodes the file to this output file. What you're not doing is you're not specifying a data rate. You're not specifying a keyframe interval. You're not specifying an audio data rate. You're not choosing a preset. So ffmpeg is going to use the defaults for all those switches. So by using command like what we saw in the last slide, you're leaving ffmpeg to make all these decisions, and basically by going with the defaults. Some of these are OK. I mean, you're not going to mess with a lot of times you don't have to specify the frame rate because it's going to use the same frame rate. A lot of times you don't have to specify the resolution because it's going to use the same resolution. A lot of times you don't have to specify the preset because it's going to use the same. It's going to use the medium preset. So a lot of these are OK, but when you're encoding for adaptive bitrate delivery, you're going to have to specify a lot of these. So a command line like this is usable if you just want to make a file smaller to play it off your hard drive. On the other hand, if you're creating a group of files for adaptive bitrate delivery, you have to do a lot more. So it's important to understand what happens when you don't specify what you want in the command string. So from my perspective, one of the most important things about delivering adaptive bitrate video is bitrate control. And how many people distribute their files using CBR at this point? How many people use VBR? OK, and I think 5 or 6 years ago, a lot of people used CBR because they felt the files were more deliverable, and you could deliver them more reliably using CBR. I think that's kind of a trend that's going away. But when I asked the same question a couple days ago in one of my pre-conference classes, a bunch of people said, yeah, we still do CBR. So I think it's important to understand what ffmpeg does if you care about it. So if you care about CBR, you care about bitrate control, it's important to know this stuff. So what I did to illustrate that for a bunch of different reasons is I create a synthetic video file with 30 seconds of talking heads followed by 30 seconds of ballet. So it's low motion, high motion, low motion, high motion. And if you use the simple bitrate control, you basically say, just give me a 5 megabit per second file. What happens is you're going to get huge variations in the bitrate of the file over the duration of the file. You're basically saying you're not specifying a bitrate control method, so it's going to use a variable bitrate technique, and you're going to see changes like this. And I've done a lot of testing, and with this file, you do see, if you're delivering under a constrained bandwidth condition, you do see a drop in quality of experience. So that is real, but I'm not sure how many people are delivering 1080p files under constrained conditions anymore. It seems like most of the files are being retrieved at 17, 18 megabit per second systems, so a 4 megabit per second file that goes up and down isn't going to cause a problem. But the tests I've done show that this can cause problems, which is why we're talking about this. So how do you set a data rate with 2-pass? And we're going to cover 2-pass operation in more detail later in the session. But basically what we're doing here is this is the analysis pass. This is the encode pass. And again, we're identifying the file, identifying the codec, identifying the bit rate, and telling ffmpeg this is pass 1. That's the analysis pass. And this language is going to change a little bit whether you're on Linux or Windows. And then this is the second pass where we're again specifying the target bit rate. So what does this give us from a bit rate control perspective? Here's the 2-pass encode. You get a little bit better bit rate control. So the average bit rate here is 5 megabits per second. Here it's 5062. The peak bit rates are about the same, but we're not seeing a different profile when it comes to controlling the data rate. So how do we do that? We create a CBR file, constant bit rate file, by specifying the target in the first line, and then the target here, the maximum rate here, and the buffer size here. And what we get there is we get a file that's a lot more consistent in terms of the average bit rate than we do here. And we also, so here the peak is 5.2 megabits per second. Here the peak is 8.5 megabits per second. So again, if you're delivering this file under constrained delivery conditions, this file is going to be a lot easier to deliver, and you're going to see a lot less stream switching with this file than with this file. The only problem with CBR is you can see transient quality issues like this. So a lot of people aren't using CBR because they're concerned about this. What you move to there is constrained VBR, where you set the target bit rate here in the first pass, and you can set the maximum bit rate. This would be 200% constrained VBR. There's like a phantom cart that nobody knows where it is, but it sounds like it's about to hit me. So this would be 200% constrained VBR. This would be 110% constrained VBR. I'm constraining the bit rate to a maximum of 5.5 megabit per second here, 10 here. And what do the two files look like? This is the 200% constrained VBR file. It looks like all the other files we created a few minutes ago. And then this is the 110% constrained VBR. So this file, I'm sorry, this is the CBR file, and this is the 110% constrained VBR file. So we're seeing a lot more consistent bit rate here, but this isn't going to have the transient frame issues. So I never use CBR. I recommend to my consulting clients to use between 110 to 150% VBR. Some go as high as 200. The quality difference for 200 just is not that significant. And I think the risk of interrupting smooth delivery is significant enough to consider not using it.
What's causing the transient frame issue?
Say it again?
What's causing the transient frame issue?
What's causing the transient frame issues? I think it's just CBR. There's so much bit rate control that sometimes in order to meet the target bit rate, they have to sacrifice frame quality.
Oh, so that's in the CBR, it's not the VBR.
Yeah, it's not the VBR. So this is slightly higher quality than CBR and avoids the transient frame issues. Okay, so moving on to other controls that you're going to want to include in your file. This is the default keyframe interval. This is the default. Where's? Is that coming from next door? Do we have a moderator in the room? Is that coming from the soundboard or? Pardon? Not that I'm aware, but let me. Okay, that was me. Good thinking. That was the, I guess, one of the keynotes. That's how I feel. Okay, so here we're showing the default keyframe interval. These are the settings that are all defaults. So if you want a keyframe interval of 250, which is fine for files you're playing back from your hard drive, this determines when you insert keyframes, what the minimum keyframe distance is going to be, and this is the threshold for inserting keyframes. And if you're OK with any of these, you just don't need to include them. So if you're encoding a file, again, for delivery from your hard drive, these are fine. And this is what it looks like in a product called Telestream Switch, where you see the yellow lines here are the keyframes, and then you see periodic keyframes at scene changes. So if you add up this number, this number, this number, and this number, it adds up to 250. For ABR delivery, typically you want shorter GOP sizes, either 2 seconds or 3 seconds. This is a 24 frame per second video, so it's a 3-second GOP size. And typically what I do is I just make the keyframe minimum the same as this. I don't want any keyframes at scene changes. And then I set this at 0, kind of make sure that there's not going to be any inserted. So this, again, is what you'd see with these controls. So we've got a keyframe every 3 seconds. And if you want to have, this is another way of getting to the same result. This is useful in some instances, particularly with Bento 4, where it doesn't recognize keyframes created with this control. And I'll get into that when we get there. So here I'm saying force keyframes, and if I'm OK with this and this, I don't have to include these. So what we're saying here is we should deliver a keyframe every 72 frames, and we should see keyframes at scene changes. So that's what we see here. We see a keyframe here, which is 72 frames, but we also see keyframes in between. So we're achieving a regular keyframe interval with keyframes at scene changes. Why do we want keyframes at scene changes? Anybody? Because that delivers slightly higher quality. How much better quality? The test that I did with the file that we looked at, the peak signal to noise ratio for no scene changes, keyframes and scene changes, was 41.22. With scene change detection, it was 41.25. So it's a totally minuscule quality difference, which is why I typically just don't mess with it. I typically just don't include keyframes at scene changes. There's no. Say it again?
Is BSNR the right metric?
It is a metric. I mean, it's VMAP is not going to be 10 points different. I mean, remember, PSNR was used by Netflix for their per title encoding engine until June of 2016. So I mean, it's not like it became garbage overnight. It's not the one I use a lot of, but it's pretty consistent with other ones. And then in terms of resolution, again, if you want the video file to be the same resolution, you don't have to include any switch if you're converting to a smaller resolution. And you don't have to worry about converting from one aspect ratio to another. Then you can use this switch. So if you're converting a 1080p file from 1080p to 720p, you can use this. On the other hand, if you're converting a movie file like Tears of Steel that isn't 16:9, and you want to be able to control the specific resolution that you get, this is the switch that you would need. So you need to use this when you're converting 4K content that isn't 16:9 down to 1080p or 720p or any other resolution beyond that as well. Frame rate is pretty simple. It's just -R, and typically that's sufficient to get things done. If you don't include this in your command line, ffmpeg will use the source frame rate. So this is not one you need to include. Preset and tuning. If you're going to choose a preset other than medium, you need to specify that with this switch. Don't include there's no space between. And then if you want to tune for tuning animation or tuning for film, still images, PSNR, SSIM, or grain, you just /tune and name the filter that you're using. And then for audio, you're going to specify the codec. And again, in most cases, if you're just using audio pass-through, you don't have to have any audio switches. If you want to change from if you want to change the bit rate, you want to change the number of channels, you want to change the sample rate, you include that in here. Otherwise, ffmpeg will use the number of channels in the source, or will use the sample rate of the source. You don't have to specify all of this stuff if you don't want to change it. We talked about multipass before. You don't need to include all the switches that are in the second pass in the first pass. And you can use a first pass multiple times. So here we're seeing, and don't include the pass 1 in the pass. That's just to designate the pass. So you would start with ffmpeg. But here we're seeing ffmpeg, the first pass, being used to create 3 passes underneath that. This is 1080p, 1080p, 720p, and 720p at a lower bit rate. So you can use the first pass multiple times. What's the benefit of that? You're saving time. You're getting no quality benefit by doing a separate first pass for each one. So you're going to save, I mean, it's not, the first pass is usually much quicker than the second pass, so you're not saving a ton of time. You can't use the first pass, again, if you're going to change the frame rate, the keyframe interval, or the profile. So if you're doing an encoding ladder that's got all high profile encoded video, you can use the same, you pretty much use the same first pass. If you're going to change the profile, again, the bit rate or the keyframe interval, you can't. Which configuration options must be in the first pass? The frame settings, so bframe and keyframe, have to be the target data rate, but not the max or the buffer size. Some people say the audio settings have to be in there, but I found that not to be true. I've included them in here just to be compliant with what other resources talk about. And then if you want to package in HLS, you would add this switch to your command string. And we'll see what that looks like on the next slide. This must be in the first and second pass. And here we're specifying the segment length. We want a 6-second segment. You have to set this if you want all segments in the playlist. And here we're calling for a single file, which is called via byte range, where the segments are called via byte range request rather than separate files that are called via the separate file name. And putting it all together, here's the first pass. We see the ffmpeg HLS switches down here, down here, down here, and down here. Now I just learned that I learned this week ffmpeg can create master playlists. I think it started, was that in March, Oliver? Or? Yeah, I mean, it doesn't document how to do it in the notes, but I just discovered that it's possible. I haven't looked at that, but from my perspective, Bento 4 is kind of a better tool because it's a lot easier, and you'll see what I'm talking about in a minute. Just wanted to cover X.265. The thing about X.265 is you can't use the same command structure. You can't use dash, configuration option, space, setting. You've got to, you can specify the preset as you did before, but all of your X.265 parameters have to be linked like this. And if you, if you don't do this, ffmpeg doesn't send an error message, it just ignores them all. So I wrote 2 chapters in 2 books. I encoded a bunch of files and didn't know that nothing was being done with these switches until somebody called, one of my people who read the book said, hey, this isn't working. And because there's no error message, I should have checked the files, I didn't, everything seemed to encode fine. Long story short, you need to make sure that you've got this command structure, and again, passes need to be here as specified. If you just do dash pass 1 like we did the other ones, it's not going to work. Again, you won't get an error message, you just won't get 2-pass encoding, it'll ignore the first pass and just encode using the second pass. So you have to be really particular when you're using X.265. Because of these various mistakes, I made the chapter in the second book, the X.265 chapter in the second book, free to download. So if you want to download that, you can see the URL here. So this is the ffmpeg in 30 minutes book. Chapter on HEVC encoding is available for download for free. OK, introduction to Bento 4. Bento 4 is a set of encoding and packaging utilities, and we'll use 3 of these. And what can you do with Bento 4 HLS generation, including master manifests? Again, that was a huge deal because ffmpeg couldn't do it until very recently. Stream manifest, transport stream files, and fragmented MP4 files. So again, what we just learned how to do is create the basic MP4 files for our ABR ladder. So the next step is how do we package these into dash and or HLS delivery? And that's what we're going to do with Bento 4. And it can convert from MP4 to fragmented MP4, create the dash packaging files, can do all this stuff. And then these are the options you can specify. We're going to cover some of these, not all of these. And again, the language is just really simple to implement. So what we're seeing here is one of the Bento 4 utilities. This is MP4 HLS. What this does is convert MP4 files into HLS packaging. And all we have to do is tell it the version number, list the files, and you could have any number of files here. And what it does is it outputs the master manifest, the stream manifests, the iframe manifest for each for trick play, and creates the MP4, the .ts fragments. So basically what the output is the master manifest here, folders which each of the 3 files that we see here, and inside these files plus the audio file is going to be a playlist for those files. So basically all you need to do is upload these files to a web server linked to this, and you've got packaged HLS files playing basically with this command line. So I mean, it really couldn't be simpler to do. And then here's how you would implement WebVTT subtitles. Here's how you would encrypt. And I'm going through it quickly because you can download this and there's not much explanation to be done. If you're using encryption, here's a link to the help file. Here's an explanation of the most prominent switches. And that's MP4 HLS. Okay, so this is the HLS utility, and now we're moving to creating dual HLS and dash from fragmented MP4 files. Okay, so what we just did was we encoded MP4 files, we packaged those to HLS and not dash. And we did that with the MP4 HLS utility. Now we're using 2 new programs in Bento 4, MP4 fragment to convert the MP4 files to fragmented MP4 output, and MP4 dash to create the dash packaged output and the HLS packaged output. Okay, so I just want to make the point that we're calling new programs. And this is step 1, step 2. So this is the first step of the process is MP4 fragment input file, output file. And you would do this for each file in the adaptive group. Once you have the files, you call MP4-HLS to add the HLS output, no split to have one long file for each encoding ladder rather than separate segments. You have to include this switch if you include this switch, and then the output, and then you list the files that you converted up here. Okay, so again, we're calling a separate utility than we saw before. We're specifying include HLS with the dash output. We're saying create one file rather than multiple segments. We use this because it has to be here when you use this. And then we list the files in the adaptive group. And what we get out of that is all this. So here are the fragmented MP4 files. Here's the stream MPD. This is what you link to for dash. Here's the master M3U8 file, which is what you link to for HLS. And here are the intermediate M3U8 files for the audio and video streams. So again, you've got one line of code. So what I would do in this case is, again, we created these files a couple slides ago with ffmpeg. Here I'm converting the MP4 files to fragmented MP4 files. Here I'm calling MP4 dash. We covered these options a moment ago. Then I'm listing the files. And from that, I get all this. So again, if it really couldn't be simpler. Obviously, encryption, captions add some level of complexity, but it's it's a lot of output for very little work. Okay, so that's the ffmpeg side. That's the Bento 4 side. Now we're going to cover the Ubuntu side. Now let me just say that this article is one I wrote for Streaming Media Magazine. It's in the Streaming Media sourcebook. There's a link to it here. And everything that I'm going to show you here is included in that article. So if you want to leave now, write down the URL, and you can do that. So I just wanted to, how many people have done batch files on Ubuntu? Okay, how many people have done only on Windows? Okay, so getting from Windows to Ubuntu, why did I choose Ubuntu? I choose Ubuntu because it's free, it has simpler automation controls than Windows, ffmpeg and Bento 4 obviously run on it, and I have it on multiple computers in my office just because every once in a while, I'm primarily a Windows shop, I've got some Macs, but I also have Ubuntu around for testing like this and for some consulting projects. But it's free to download, it's generally pretty easy to use, it's got a GUI that makes it simple, and getting to the terminal is actually pretty simple as well. The only thing to know from a batch file perspective is that if this is the ffmpeg equivalent under Windows, when you convert that to Ubuntu, you have to put what's called the shebang up here, which tells Ubuntu which bash language you're using, and then you use the same ffmpeg command string. Instead of saving it as a batch file, you typically save it as a .sh file. I don't even think that's necessary. I just think that's kind of what people do. And then the funky thing about Ubuntu is that, so you're in the terminal, you save this off as batch.sh, and then you try and run the batch, and it says command not available or permission denied. And so every time you create a batch file under under Ubuntu, you have to get permission to run it by typing this. So and this is chmod plus x and name the batch file. And that gives you permission to run it. And then to run the file, it's / name a file. So the only thing different between Ubuntu and Windows is, number one, the shebang. Number two, you got to get permission to run the file, and there's a little bit of a different convention for actually running the file. But knowing these will just save you a lot of time, and I had to work through all this and figure it out myself, but that's all there is to it. It's really not that hard. Okay, so that's what can we do with a bash script. So the first thing I did, and this is in the article, is I wanted to tackle, and so I created that ffmpeg training materials. So I shot screen cams, I edited in Premiere, I output from Premiere. I've got these really high bitrate files that I want to upload, and I've got 30 of them. Then I want to use CRF encoding to encode them because that's going to give me a certain quality level at the lowest possible bitrate. So I've got 30 files I want to encode. I can create a command script that does that, but it's like, is there an easier way? And there is an easier way. So all you have to do is create what's called a for loop. And again, what we're trying to accomplish here is encode a bunch of files that are in a folder. And this can be a watch folder, and we're going to get how to operate in a watch folder in a minute. But all you have to do in Ubuntu is, again, here's the shebang. And then you're saying for, this starts the for loop. And the for loop is going to encode this command string on all files that you specify. So we're basically saying for the files in this folder that have a .mp4 extension, do this ffmpeg command string. Okay? And then this stuff is just stuff you have to, this is just the technical requirements of, it's going to insert the file name here. It's going to insert the file name here with the _CRF extension. And so I use this, and 30 files are encoded to CRF. And again, running one 5-line script, in order to run it, I've got to go through the chmod permission process, and then run the batch file this way, and it runs. So that was the first thing I learned to do, and you can read about it in the article, and you can actually download the bash scripts here. Not that it would take too long to recreate that. So we learned at the start of this how to encode to ffmpeg and how to convert with Bento 4. What we're seeing here is how to automate all that. And this looks like a bunch of scary stuff, but it's really just another for loop with a couple of modifications necessary to make it work smoothly. So here's the shebang, here's the for loop, here's the do. So we're basically saying for every file in the folder, do all this stuff. And you've already learned how to do all this stuff here. This is the make the files in ffmpeg. This is fragment the files in Bento 4. This is make the dash and HLS manifest. The only thing that's funky is the naming convention. Does that make sense? And so what we're basically saying for all the files here, first I'm going to make a directory to send all the encoded files to that new directory. And I'm going to make a directory for each file in the folder. Why am I doing that? Because if you send more MP4 files into that same folder, with the watch folder running, each time it sees the file, it's going to re-encode that file. So you're going to get recursive operation. Here we're going to make 4 MP4 files. There would be 4 MP4 files that this script would see and start to encode. So to avoid that, the first thing I do is make a directory. And I'm going to put all the output from this encode in that directory. And in that way, this for loop won't try and re-encode the files. So step one is make the directory. And then all this stuff is the same as what we learned before. The only difference is the file naming conventions. And that stuff is complex, but it's not hard. You just need to make sure you're naming the files correctly, and then that will work. And then everything else is the same that we learned before. The last thing we do is move the source file to this folder to get it out of that directory, and then we're done. And this will essentially, for the 30 files that I talked about a minute ago, this would package all those files into, this would transcode all the files into these iterations. It would create fragmented MP4 files from the files I just created, and then it would package those for dash and HLS. And then the last piece of the puzzle is watch folder operation. And this is another reason I liked Ubuntu, is we had, basically what we do is we create the script that we just created, and then we create this watch folder script that basically watches that folder, and anytime there's a new file that goes into the folder, it executes the script. So what we would do to run this script manually, again, we'd create the script, get permission, then run it. We put that script in this folder, and then we run the watch folder script. And then any file you put in the watch folder will trigger this script, and that will run, and then it'll stop when all those files are encoded. So it really is quite simple to create a watch folder operation that does all of your encoding for you using ffmpeg and Bento 4. Any questions? So I would urge you okay, I'm just going to trying to get back to the first file or the first screen. I'd urge you to download the handouts. That's going to give you everything you learned. And then if you go to the article, you'll see a textual explanation for everything we learned on the Bento 4 side. Pardon?
This covers the VOD case. So if you want to live streaming, what are the open source tools?
So for live streaming, what are the Bento tools? You know, I'm not comfortable. I think they're all available for live, but I've never done it, so I'm not comfortable. Really what you should do is, yeah, I mean, ffmpeg live is actually, it's covered in the book, the command strings to do a live encode, but the live packaging is, if you I don't know if the Real Eyes guys are going to be doing any more presentations, but if you go to a presentation that June, David are presenting in, or you can otherwise grab them, then I'm sure they'll know the answer to that question. I just haven't looked at the live use case. Any other questions? Pardon? Right. Looks like it can do what? Including the master? Is it just Linux that does the manifest?
On Linux and on Mac we use the Apple's.
Okay. So it sounds like, again, I'm comfortable discussing something I haven't actually done, but the master manifest is new, and as I said, I learned that, I think, Monday. So sorry I didn't cover that. Who's worked with the master manifest tool with ffmpeg? Have you? How's that compared to Bento? Is it same? Okay.
When I try to create a HLS out of SendIn4 or something, and if I'm trying to have demarks audio, will there be any syncing issue?
Any synchron?
Syncing issue, audio video syncing?
I mean, there shouldn't be. So are there any syncing issues if you use separate audio and video? I don't think so, because I think a lot of people are using that workflow. I mean, you have to for multiple languages, so I don't think that would be a problem. Any other questions? Okay, let's go to lunch.